Okay guys, in this video I'm going to cover economic efficiency and taxation, so the inefficiencies in markets caused by taxation. So in this video we're going to go over taxation and economic efficiency, then we're going to go over optimal taxation, and we'll go over optimal taxation in the specific case of income. Okay, so what about taxation and economic efficiency? Attempts to minimize tax burdens have efficiency costs to society. This is because without a market failure, your social efficiency is maximized. So if you introduce a tax, you will end up in a situation in a market where you can't be at that equilibrium any longer, and so you will have some loss in efficiency. So a market that doesn't have market failures will lead us to an efficient outcome. Remember, we've discussed efficiency quite a lot in this class, but it's just that idea that the amount of goods that people want is matching up with the amount that people want to produce. It's being done cost efficiently. We're doing it as unwasteful as we can. Okay, and this idea that we lose some efficiency, again, right, we always have that issue where this word efficiency is sort of sterilized, right? But I want you to think about that meaningful sense that we've been using in this class to discuss this idea of productive and allocative efficiency, right? So when we have a market functioning well, it is giving us what we want. So when I say we're losing efficiency, we're losing social efficiency, saying people's lives are made worse off. People's well-being is worse. And the reason that this happens when we introduce taxes, the reason we get less social efficiency, less well-being, is because taxes change behavior. And in the absence of a market failure, markets will maximize that well-being. So if we introduce a tax in a market that's not otherwise inefficient because of market failure, then we must necessarily be at a different situation than if we hadn't introduced the tax. Okay, so remember when we're talking about tax incidence, in the previous lectures, we were making the point that tax incidence is about prices, and I sort of belabored that point of saying we're not really thinking about quantities. And the reason for that is because tax incidence is about prices, and tax efficiency is about quantities, right? So tax inefficiency is the amount of social efficiency sacrificed by society when trades are impeded by taxes. Okay, so trade is mutually beneficial. And what I mean by that is that when a trade is executed, it's because both sides of the trade, assuming there's no, coercion going on. If people are free to act, this is what we mean by a free market. If there's no coercion happening, then the two people involved in a trade both believe they are better off. All right, I've given several examples earlier in this class, but suppose, I have golf clubs that I'm not using, and my neighbor has a lawnmower that he's not using, and I need a lawnmower, and he would like to play some golf, and we make a trade. Well, what happened there? I was better off because I got something I would rather have, and he's better off because he got something he would rather have. So trade has this ability to make everyone better off. Now, when we introduce a tax, so suppose that there was a tax on trading your lawnmower to your neighbor, right? That would impede this trade, and so my neighbor and I would both be worse off, right? Because I don't have a lawnmower that I would like to have because I don't want to trade him a golf club and pay $10 in taxes, or whatever a number that would be. And so because trade is mutually beneficial, it must be the case that when we introduce taxes, we're sacrificing some well-being in a market because of that. So when, for example, you cover monopoly in your principles micro class, you'll talk about the loss that happens from having a monopoly in a market. And the important lesson there is it's not that the prices are higher, although that is an outcome of monopolies and that is a thing consumers don't like. The real problem with monopoly behavior is the same fundamental reason as what I'm talking about here, which is it reduces the number of trades. So those trades that would have made both sides more well off are now stopped. They're now decreased. They're impeded, and that makes us worse off. So let's take a look at exactly that idea, and we'll do these numerical examples as we have done in the past. And let's take a look at just a straightforward situation. So we have a tax imposed on sellers, and let's say the initial equilibrium price was $1.50, and the tax gets imposed and the new equilibrium price is $1.80, right? All this should look familiar from when we're talking about tax incidence. So what happens here? Well, all of this stuff that we were talking about here is what we talked about in tax incidence, but we also want to be thinking about what's happening down here. So say we're selling 100 units before the tax was imposed. Now, after the tax, there are only 90 units being sold, right? So we have this situation where, okay, there's the tax incidence, and we can see very clearly in this case, right, that there's the consumer incidence like we talked about before, and there's the producer incidence that we talked about, and how the changes in the market shift that nominal, the statutory tax burden that we put 50 cents, make note of that here, 50 cents of tax burden that happened here, and part of it is shifted over to the consumers in higher prices that they now face. But the other thing that's happening in this market is that we have a situation where we're actually losing out on beneficial trades, right? So there's 10 trades, 10 interactions, 10 transactions that are not happening because we ended up in a situation where the tax made that less appealing, right? Fewer that producers want to make because they face this higher tax, fewer that consumers want to make because they face this higher price. Now, in a situation where that happens because of market forces, well, that's just a real reflection of the costs and benefits at play. In a situation where we put the tax on, this ends up being trades that we could have had in the absence of the tax, so it's arbitrary, it's artificial in a sense. So the question is, what is the value of these trades? Well, when we look at demand curve relative to the price and supply curve relative to the price, we get this idea of surplus, right? So if I'm this consumer, I'm here, and at whatever price it is that I would be induced into, so let's just say that's like $2, I would buy whatever unit, and let's just say that's the 80th unit. So that's the individual willingness to pay. Well, that distance between that equilibrium price that I would pay and where I was at on that curve means I would have paid $2, but I only had to pay $1.50. Remember, this is all pre-tax. So we're facing that $1.50 price. That's extra value that I was getting. That's surplus. And it turns out that that well-being that I get from interacting in this market, I get $2 of value for $1.50. This equilibrium outcome here is where that is maximized, obviously, right? Because if we made a trade over here, we would see that the cost is higher than the benefit. And if we stop somewhere over here, arbitrarily along that line, stop somewhere over here, we see that there's lots of trades over to the right that would be beneficial because the willingness to pay, that's the demand curve, the benefit derived from it, is higher than the cost, right? So anytime the demand is higher than the cost for a particular unit, we see that there's that benefit, that surplus that we're talking about, and that's how we get economic efficiency. This should all ring a bell. It's straight out of any Principles Micro class. Going to be a staple of that class. So I'm tapping into that same idea here. So the question is, now we have 10 fewer units being transacted. How do I know how much value was lost? Well, the value of, for example, the going down to the 90th unit from the 91st unit, right, means that the value that consumers placed over suppliers is a full 50 cents. Of course, that's the biggest, that's the most expensive loss, right? The further we move left, the more loss we get. More on that in a minute. And this first unit, if we only went down from 100 to 99, we'd only lose one unit, and that unit would have the smallest sort of gap there. Well, if we add up all of the valuations, the differential valuations between the demand and the supply, right, the willingness to pay and the willingness to accept, the value of the benefit and the cost to produce, if I add up all those differences, that's how I know what the value of the units that weren't sold. And we call this deadweight loss. So this is deadweight loss. And that is just lost surplus. And surplus, right? Lost well-being. Lost benefit. Like all the different ways that we would characterize that, right? So let's take a look then. If all the way from this unit over to this unit, and the valuation ranging up to here, that means this entire area here is loss. Right, this entire area in here, that triangle, so we give it labels, right? A, B, C. That triangle, ABC, is our deadweight loss in this scenario. So that gives us a sense of how is it that how is it that taxes are inefficient? We lose economic efficiency. What economic efficiency is that? It's deadweight loss. And this deadweight loss, this is how we evaluate that. Okay, so what then determines how much or what kind of loss we face in a market when a tax is imposed? Well, the answer to that depends on the determinants of deadweight loss. Deadweight loss is a function of the elasticities of supply and demand. So higher elasticities cause us to have more deadweight loss. This is because there are more substitutes and more alternative options for producers and consumers. So when you put a tax, this benefit that people were getting, they substitute away from it quicker because they have more alternatives. It changes their behavior more. So by changing the behavior more, we end up with more loss, more deadweight loss, less well-being, higher consequences, right? The other thing that's true is that deadweight loss rises with the square of the tax. The upshot of this is that the higher the tax rate, the greater the distortion from increases. So going from 0 to 1% tax is not as damaging as going from 1% to 2% tax. So let's see that in action. I've got the exact same graph as I had here. I'm going to keep it a little simpler by not showing the supply valuations, the willingness to accept associated with each situation. But let's say same situation. This is 100 and this is 90. This tax increase, same as before, that's 50 cents. But now we have another scenario. And in this scenario, we see that there's an additional 50 cents tacked on for a total of $1 worth of taxation, right? So I made those the same on purpose. And it was initially the case that the equilibrium clearing price was 150, and then it went up to 180, and we'll say, just for hypothetical sake, we'll say that went up to 210. So we see this increasing price and this increasing outcome. But what we're really interested in, right, is this change. Say that takes us down to just 80, right? But remember, the further we go back, right, so this individual values this product more highly than this individual because his willingness to pay is higher, right? But the further we go back, right, the further we go down the supply curve, meaning that the production of this unit is higher cost-wise than the production of this unit, right? So the first unit that's made should be what? Should go to whoever values this good more than anyone else. Their willingness to pay will be the highest for the very first one. And the production cost of that, in terms of the supply curve, will be the lowest, right? The marginal cost of that production will generally be the lowest. Okay, so let's take a look then at what this does to our deadweight loss. So in the same way, now we'll make it A, B, C, D, and E, right? What's the original scenario? So now I've renamed it, but bear with me, right? There's our deadweight loss. There's our deadweight loss. So we have that same initial deadweight loss. Deadweight loss 1 is the triangle BCD. And then, of course, we knew if we added more taxes that it would be the case that the deadweight loss would get larger. But how large? Now we're talking about a deadweight loss from A to C to E. So it's this triangle, right? And so it's this entire area. Notice that it includes the first area, but it adds all this area back here, right? It adds all this area back here. So obviously, dead weight loss 2, triangle ACE, it is bigger than BCD, and we knew that it would be, but it's gone up at an increasing rate. So it's not double, right? So dead weight loss 2 is more than twice as big as dead weight loss 1. Right. The other way to say that obviously would be ACE is greater than 2 times BCD, right? Because if we just doubled it, that's a linear increase. But I'm saying this is going up at an increasing rate. So we have this enormous increase for the same size tax increase. So the tax rate increases at the inefficiency increases at the square of the tax rate. So obviously in this case, you could do the math on this situation, right? Because you actually can calculate the volume of, the area of the triangle, right? Because you have a base of 50 cents and you have 10 units. And then obviously you guys can calculate, just assume that point E is associated with like $1.10. Now the base is $1 and the height of the triangle is 20 units. You can see that that's greater than merely twice as much, right? It's actually substantially large, increasing at the square. Okay, so the tax rate and dead weight loss. This leads us to an important point. Governments should smooth tax rates over time. This marginal increase in dead weight loss rising with the tax rates means governments, if they're increasing tax rates, should do it in small increments over time, rather than large jumps in the short run, even if they plan to reduce the taxes afterwards. So it would be the case that even if the government had some large thing to finance in the short run, so perhaps a war would be an example of this, they're better off raising the tax rate slowly over time if they can, as opposed to raising the taxes very quickly and then dropping them back very quickly. So 1 year of 40% taxation when the baseline's been 20 is much more burdensome than if you were to raise your tax rate 1% at a time from 20% up to 40. That would take 20 years. That would be less of a cost because of that. That's a linear increase, but the damage is done at a square. So if you increase by 20 percentage points from 20% up to 40, 100% increase, but 20 percentage point increase, the damage of that would be quite large compared to just a linear increase, just 1% of the time. Notice that the 1% of the time would still do the square of the damage, but the square of 1 percentage point compared to the square of 20 percentage points is going to be quite a bit different. So you're adding up the totality of the damage over time. Now let's turn to optimal taxation. Optimal taxation minimizes the deadweight loss for a given level of revenue. So we need to collect a certain level of revenue. That's surely what you were thinking earlier on in this lecture is, right, but we have to collect some revenue. So how do we do that if it makes people worse off when we do it? Well, that's a philosophical question sort of outside the scope of this particular lecture, but definitely something worth thinking about. But given that we have to collect a certain level of revenue, what should we do? We should make people lose social inefficiency as little as possible, right? We should minimize that deadweight loss. And this is where we're introduced to a new idea called the Ramsey rule. The Ramsey rule says that to minimize the deadweight loss of a tax system while raising a fixed amount of revenue, taxes should be set across commodities such that the ratio of the marginal deadweight loss to the marginal revenue raised is equal across commodities. So we want to try to minimize the choices that people are having to make between goods by trying to spread out the loss that's happening between each of those goods for each unit of revenue collected by the government in order to fund that revenue level that we want to get to. So the deadweight loss per dollar of tax revenue associated with an additional dollar of taxes should be equal for all commodities. That'd be another way to say what I have written here on the page, right? So if you have a tax on good A and it has a marginal amount of deadweight loss per marginal dollar collected in revenue, and that ratio is higher than the deadweight loss from an additional unit of revenue gained from taxing good B, taxing good A that way causes more inefficiency per dollar of revenue raised than does taxing B, right? So you can raise the taxes on B and cause less deadweight loss, right? So let's take a really brief numerical example just to highlight that. So we're in a situation where for good B, the marginal deadweight loss ratio to marginal revenue. So we collect one more dollar, and let's say that causes $2 in total value of damage loss for collecting one additional dollar. But for A, this same ratio is $4. So what that means, the intuition is I get $4 less and I lose $4 in well-being for collecting a single dollar in revenue from taxing good A, whereas if I tax good B and get an extra dollar in revenue, it only causes us to lose $2 in well-being, right? So the margin, the ratios between them, this idea lambda, right? The lambda for B is less than the lambda for A, so we should choose to tax B rather than tax A. Okay, so if it's the case, right, that the lambda is very high, that's this letter lambda, if that ratio is very, very high, then in order to take that dollar in revenue, it must be the case that the value of that additional resources to the public being collected by the government must have very, very high value, right? So it must be the case that if we're going to do a lot of damage to the social welfare, there needs to be a reason. And that reason needs to be that for whatever reason, the government really needs to have this dollar, right? And so we can imagine situations like that. You know, you have two groups of people and they're at war, and group A is thinking, well, how do we fund this war? We might really need that dollar. Now, not advocating for war or funding war or whatever, but we can just imagine a very trite scenario wherein Group B might destroy Group A if Group A doesn't raise more in taxes in order to finance its military, right? Obviously, most, if not virtually all, wars are unjust. But just we can imagine a scenario in which you would actually need, as Group A, to raise a bunch of taxes to fund it, right? And we can imagine other scenarios where we might really be genuinely convinced that the additional value of a dollar in taxes might be high, that even if the amount of deadweight loss that we get for every dollar taxed is very high, that we might still want those dollars to be taken in taxes. Okay, so this is the same idea as our marginal cost equal to our marginal benefit, right? And so we want to evaluate the benefit that we're getting from the tax dollars versus the marginal cost of that, which is the marginal deadweight loss per marginal unit of revenue, so every dollar taxed. We would want these taxation to work out exactly the same as marginal cost equal to marginal benefit. So if this is higher than this, then we want to keep taxing. We're saying the tax dollars used are much more valuable than the social welfare loss that we're getting from that. But if this is higher than this, then we want to stop, and we actually want to reduce the amount that we're taking in taxes because our uses are relatively low value compared to the cost of taking it. So just straightforward cost-benefit analysis in economics just applied to taxes. Okay, notice that this is very good in theory, but it's generally the case that lambda is unknown. And it's also important to know that even if there is benefit from lambda, there's some endogeneity there where government activity crowds out private activity. So that will tend to lower lambda and raise the marginal deadweight loss per tax dollar revenue over time as well. So there's two very important sort of caveats there. Okay, so what are the implications of the Ramsey rule? The idea here is that same idea that we met back when we were talking about how is dead weight loss related to elasticity. The Ramsey rule has the implication that the optimal tax rate is related to the inverse of the elasticity. So here's the tax rate. I'm saying it's star because it's the optimal rate. And I'm saying it's related to the inverse of elasticity. So that's the symbol eta. Eta for elasticity. We can write that down just so we remember it in the future. This is elasticity. Right? So it's related to the inverse of the elasticity. Formulating the Ramsey rule this way, right? So I'm saying this equation is equivalent to the equation we saw previously. Really highlights two particular factors that we have to take into account when balancing taxation and considering the Ramsey rule, right? The first is the elasticity rule. So when the elasticity of demand for a good is high, it should be taxed low, and when the elasticity is low, the tax rate should be high. Thus, the dead weight loss from any tax is going to rise with elasticity, so efficiency is enhanced by taxing more inelastic demanded goods rather than more elastically demanded goods. The second rule is the broad base rule. So it's better to tax a wide variety of goods at a moderate rate than to tax few goods at a very high rate. And of course, this is because the marginal dead weight loss from tax rises, right? So if I pile all my taxes onto good A, then when I tax at 1%, it will do some damage. When I tax at 2%, it will do the square of that damage. If I tax at 3%, again, rising at the squared rate, so the rates go up very highly. So I'd rather tax good A 1% and good B 1%, all else equal, than I would tax good A 2% and good B 0%. Right? This is that same idea as tax smoothing as what we saw before, right? So all of that is a bit complex. So what I want to show is how this would work in practice using those simple examples that we have seen before. All right, so consider a situation where we have relatively inelastic demand. Recognize this. To a situation where we place the same tax. So I tried to draw these roughly the same size. Right, there's our good old 50-cent tax, just like before. Trying to make these look very similar so you guys can see how this would play out. 50-cent tax, excuse me. And we know this is relatively elastic. Okay, so two unit elastic supply curves, an inelastic demand curve and an elastic demand curve. What are the implications for our dead weight loss? In a very elastic situation, we have dead weight loss that looks like this. In our that's inelastic. In our elastic situation, we have dead weight loss that looks like this. And you can just see sort of visually that the dead weight loss is much greater in the second scenario. So EFG is greater than ABC, so more dead weight loss in the second scenario, in that second scenario. So just a sort of straightforward visual application of seeing how inelasticity and elasticity from the Ramsey rule translates into efficiency loss. The other thing we want to look at is optimal taxation on income. So tax impacts the size of the tax base because it changes behavior. So the rate of taxation on incomes will determine the size of income subject to taxation. In economics, we'd call this idea endogeneity, right? So the taxes affect the income, but that changes the amount of income. So there's changes in the tax base, so that changes the amount of taxation, right? So let's take a look at a very common idea called the Laffer curve by a economist who sort of looked at this idea about the relationship between the tax rate and the tax revenue, specifically on income, right? So the idea is somewhat straightforward, right? Initially, if you set taxes to 0 and you raise the tax rate by moving right, your tax revenues climb. And this is true up to some point, tax star, right? And there you've maximized tax revenue. Now, should we maximize tax revenue? Not necessarily, right? Because it should be subject to all those ideas that we talked about before in relation to how much taxes we should take should be related to the deadweight law. So this is just the idea of what happens to the tax base as we raise tax rates. At some point, though, by raising tax rates on income, you've decreased the incentive for people to work and to make money sufficiently that the amount that you tax actually goes down because people begin to work less and less as their marginal benefit for an hour worked goes down because of taxation. And this is obviously true because if we just kept raising taxes until the point that we had 100% taxation, no one would work, right? If you agreed to a job, you said $10 an hour job, and then you realized, okay, but I'm being taxed at $10 an hour for every hour I work, I get $0 per hour worked, you would stop working. So it's just self-evidently true. Of course, the Laffer curve has a long history of being used in politics as a reason to raise or lower income tax rates, and sort of what this actual level is a fairly big debate in the empirical literature. So the other consideration in optimal income tax is the goal. And the goal of optimal income tax analysis is to identify a way that we set up the taxes across income groups that maximizes social welfare while recognizing that raising tax rates has conflicting and even potentially negative effects on tax revenues themselves. So the implication of this is that you should set income taxes across groups such that the marginal utility per dollar of revenue is equal to that same lambda that we saw before. So MU is the marginal utility of individual I, and MR is the marginal revenue raised from taxing that individual, and lambda is the value of your additional government revenues, same as we discussed before. So the optimal income tax system is one in which the marginal utility per dollar of revenue raised is equalized across individuals. So people have different amount of value per dollar of income, and so if you take the exact same dollar amount from everyone, that's not actually fair because some people get more benefit from those dollars than others. So individual marginal utility is a declining function of individual consumption, just diminishing marginal returns, right? It's that same idea that we'd met before. The more you consume, the less utility you get from that. Just, money is 1/2 of all exchanges. So if we have less resources available to us in the form of money, then you're going to consume less. All right, so let's take a look here, right, at a way to evaluate that. The two ways, as we've discussed before, are vertical equity and behavioral responses to sort of evaluate this in terms of fairness, much like the discussion we had before. This outcome, the marginal utility to marginal revenue equaling that value of government dollar in taxation and probably spent, represents a combination between two considerations, or as economists would call this, a trade-off, right? So in the case of our taxation before, our optimal taxes trade off on the elasticity and that broad base rule. In the case of income taxes, we're thinking about two specific things. Very similarly, we want to balance vertical equity, this idea that social welfare is maximized when those who have a high level of consumption and thus low marginal utility are taxed more heavily. Straightforward, right? If you take $1 away from a billionaire, it hurts them less than if you take $1 away from the average person. and those who have a low level of consumption, so thus a high marginal utility, are taxed less heavily. The other thing we want to balance is behavioral responses. So as taxes rise on any group, individuals in that group respond by earning less income. This is the Laffer curve. And this means that an additional increase in taxes will raise less revenue because of the base of taxation getting smaller. So let's look at an example here. So here we have a relatively poor and relatively rich person, and these are their marginal utilities, right? And so you can see that the ratio, that MU over MR thing, is quite different at each level of taxation, right? So what's the marginal revenue to marginal utility when we're at 10%? That is quite a bit lower than for the rich person than it is for the poor person, as we see here, right? And if we set the tax rate to 20% for everybody, then we see that this marginal utility is quite a bit, that ratio is quite a bit lower than in this scenario. So our equity and fairness considerations in taxation should reflect this. So we say, well, where are the two ratios equal? That's if we tax the poor person at 10% and the rich person at 20%. That's a progressive income tax.